Hi, year 11s, this is Mr. Lim here again, and this is our second video on acids and bases. We're going to be learning about the Arrhenius theory of acids and bases, so let's get started. All right, so this is what we're going to learn about Arrhenius theory. All right, so Arrhenius theory, let's have a look. Okay, well, when trying to discover what made some substances acidic, so trying to find out what made some things basics and some things neutral and some things acidic, this dude's font Arrhenius, right, proposed the following characteristics of acids and bases. Acids are substances that have a hydrogen in their structure and form hydrogen ions in solution, right? So a hydrogen ion might look like this, H plus ion. Bases, on the other hand, are substances that have a hydroxide in their structure and form hydroxide ions in solution. All right, so a hydroxide ion, OH minus. And so that's what this font Arrhenius proposed that acids and bases were, right? Just things that have these hydrogen and hydroxide ions in solution, and they contain them within their structure. That's where they get them from, right? So let's have a look. So these two characteristics could reliably explain some of the characteristics of acids and bases, as were known at the time when Arrhenius proposed the theory. So if things taste sour or bitter, that's because they have hydrogen or hydroxide ions in them, right? Those are the things that make them taste like that. They have the ability to conduct electricity in solution form. That's because, you know, they've got hydrogen ions or anions, right? So that would be the acids, the hydrogen ions and anions, which are the negative ions of the acid, and hydroxide ions and cations to act as mobile charged particles. Okay, so those ions in solution acted as mobile charged particles. They have the ability to dissolve certain metals or corrode them. All right, so that would be the action of the hydrogen and hydroxide ions. They react in predictable ways, okay, again, due to the hydroxide and the hydrogen ions. And then when acids and bases combine, they would neutralize each other. This is a property, so why would that be? Because when hydrogen and hydroxide combine, they form water. All right, so the reaction would be H plus OH minus goes to H2O, right? And that was the reason why Arrhenius thought these particular things. All right, so let's have a look. So substances that are acidic or basic can be shown in equations by forming hydrogen and hydroxide ions. So HCl would turn into H plus Cl minus, okay? And this might be when it goes from a gaseous form to aqueous forms, because remember, we are dissolving them in water, right? HNO3, again, could be turned into H plus NO3 minus. NaOH would be turned into Na plus and OH minus. And barium hydroxide, because it's got two hydroxides in there, it's Ba2 plus and OH minus, 2 OH minus. All right, so the idea is that acids can have multiple of these hydrogen and hydroxide ions, and then you'd have to write them out in a reaction to show that they are acidic or basic. All right, so let's have a look here. But there are limitations to the Arrhenius theory, okay? And then they propose different types of theories to explain these things, and we'll go through those in later lessons, okay? But not all acids or bases exist in solution form. So they can exist in different forms as well. So Arrhenius theory only accounts for acids and bases in solution. Not all bases and acids have hydrogen or hydroxide in their structure. And the hydrogen ion itself is too unstable in solution. It would rather exist as a hydronium ion. The idea is that this H plus is just a proton with no electron, and that would be very unstable. So what it does is that when it's near water, it will go and turn into a H3O plus. Okay, and so these are hydronium ions, these H3O pluses, they're hydronium ions, and this is how they actually exist. Okay, however, in year 11, we will use the Arrhenius theory of acids and bases, but you'll learn more about other newer theories in year 12. We will use the hydrogen and hydroxide ions in chemical equations, but recognize that this is a simplified version, and we'll be learning more about it later. So effectively, when we ask you to react an acid with something, you'll be reacting the H plus with that particular thing. All right. All right, that's it. Adios.